Hello community, great that you are back. Logic lies on LLM, let's talk about it. Why? I picked 5 papers of today, June 23rd, 2025. And they have one topic. It's about challenges in LLM. So let's have a look at this. I think maybe I painted here a picture of AI that we know everything and everything is known, and this is not the case. So therefore today I want to show you the challenges that we face today for large language model and a particular reasoning. Now LLMs are great, but the more we push those LLMs to creative task or mission critical application, we do encounter fundamental limitations of our LLMs. And if you want, these 3 papers show us more or less 3 interconnected topics. The crisis of an internal consistencies, because the LLMs, the same LLM, contradict its own reasoning, even within the same context, the same domain, failing here at basic logical coherence. And this is not an LLM you want in an AI agent who does health, medicine, or your finance. We do have an inefficiency of sort, and you might say, okay, I have to pay more. It is not efficient. I have to pay more token. I see more token. Yeah, but it is computationally expensive. It is slow, and this is not necessary. So also this we can optimize. And then, and this is really now something, the absence here of a formal grounding of the information. Huh? And you might ask, why is this the case? Because simply our language models, they lack a native understanding of structured real-world concepts like time, causality, probability, and making here their reasoning fragile and unverifiable because we just have a next token probability distribution prediction, but not a general understanding like a real complex world model. So let's start this off, and you might say, yeah, but this is, yeah, it concerns you here. Today, June 23rd, MIT, Massachusetts Institute of Technology said, hey, we found here, and we did here an experiment here, researcher found that non-clinical information in the patient messages, like a typo, or you just add an extra white space, or you have a language that is a little bit non-typical, reduces here the accuracy of an AI model in medical significantly. So, and they tell us here, MIT, making stylistic or grammarly changes to messages increase the likelihood the LLM will recommend suddenly that a patient, where it gets the data, should self-manage their health condition rather than come into an appointment, so where the patient should seek medical care. And when they evaluated the AI recommendation by human medical professionals, they found that AI is not performing here in any way, in any optimal form. And they said, hey, we had a look at this and have a look at the study. I think it's beautiful. And they say the findings of MIT indicate that LLMs take non-clinical information like an extra white space. Who cares about an extra white space? But in the training data of this particular LLM, maybe there were some double white spaces or extra white spaces. And then the pattern was a different one. And now the LLM sees not the semantic information of the medical information, but hey, there's a double white space. So therefore I have to activate another pattern and not a, if you want, linguistic, semantic, medical reasoning process. It is unbelievable. AI is a pattern machine, but you don't know what pattern activates this machine. So let's say we face 3 challenges today. And I want to be realistic, only the papers that I've shown you of 23rd June 2025. The crisis of internal consistency. Why? Now, this is the first paper here. Existing LLMs are not self-consistent for simple tasks. We're not talking about high complexity tasks, nothing at all. Simple task. And this is here from Tsinghua University and Shanghai AI Laboratory. And have a look at this paper. They have a GitHub and they say, hey, simple problem. LLMs lack a robust logical coherence in their data, in their output. Because in the easiest case, imagine a model states that A is before B and B is before C. It should be logically infer A is before C. However, the reasoning shows that LLM frequently violate those relations, creating impossible internal world models for themselves. And those models are not transparent. We don't see the reasoning process from quite a lot of models. We don't even have an idea how it came to one conclusion that could be catastrophic. And here for this particular paper, the researcher tested here quite a lot of models from Llama 3 to GPT-4 Omni to DeepSeek R1 on simple tasks, on two-dimensional space-time. And they said no model is fully self-consistent. Even state-of-the-art model exhibits significant inconsistencies. US city locations. We found solutions that are geographically impossible. No? Problem is not just about factual errors, but about also the breakdown of the logical decomposition, the reduction of a complex problems into multiple less complicated problems. Massive error prone. Have a look at the study. It's really eye-opening what you think that an LLM should be able to do, and then if you check for this capability, you see quite some difference. Now the beauty is always not just to show that you have a problem, but to come up with two solutions. And the authors here used here, thank you to all the authors, two fixes. You have a graph fixing algorithm and an energy-based model fixing algorithm. So great, but you know what? Those models here are post hoc corrections. The model itself remains fundamentally inconsistent. And if you use this model at the core of your agent will be fundamentally inconsistent. And this is here a quote from the authors. So, do not expect 100% confidence from an AI model. It is not providing this. And the author even found that if you start now fine-tuning, and they did, of course, smaller model for budgetary reasons, on real factual data, you think you would here increase the performance. But what they found that sometimes this increases the inconsistency score of this model, suggesting that even simply feeding more knowledge does not fix the underlying reasoning flaw, because the complexity when this pattern has been integrated or imprinted here on the LLM was so dominant that simply providing here some fine-tuning with some more knowledge that is not exactly here in the reasoning trace of the pre-trained data set, it has almost no effect or even a negative effect. Please keep this in mind. It can go wrong if you start to fine-tune. What about efficiency? What about cost? What about energy? What about your money? Now, you might say, okay, in this publication, National University of Singapore, ConciseHint, boosting efficient reasoning, and he says, yeah, via a continuous concise hints during the generation of the output. And you say, no, you're not telling me what I think that it is. Oh yeah, I'm telling you this is exactly what you think that it is. So the core problem is reasoning, chain of thought, incredibly verbose models generate numerous intermediate tokens, self-correction, filler phrases. Let me think about this in detail because today is Monday, and yes, all this computes here. Additional cost, additional latency, large reasoning model, expensive and slow, especially the large reasoning models. And here this paper, and this is why I show it to you, published today, proposes here a new method, this ConciseHint. So instead of a one-time prompt, it continues now, injects small logical causal hints into the reasoning chain of this particular LLM to encourage here the conciseness and the coherence of the answer given. Can you imagine this? You are an AI model and you are given here a task, and then you always hear a voice here in the background of your mind, so to speak. No? So we are now here on the planet Mars, and we are now solving this planet, and you have this budget, and you have this kind of energy budget available. My goodness. So always injects hints for the reasoning chain. And they said, okay, we have to do this in a clever way. No? The intervention must be adaptive. So we have some complexity adaptive intervals. The frequency of the hint has to change dynamically, otherwise this AI is going crazy like any other human would do. And the position of the injection has also to be adaptive. No? Not always at the beginning, not always at the end. We really have We want that the system learns here from different positioning of those hints so that it can integrate it somehow in its reasoning traces, in its reasoning progresses. And they found, well, we have even a fundamental trade-off, no? Because if you overdo it, if you're overly aggressively hinting here, the accuracy degrades. The accuracy goes down, especially on real complex tasks, because the model gets so much information, redundant information, that the complexity capability is reduced. Great. You might think this is not true, no? This is not possible. We're at the end of June 2025. We have the best models in the world. We are unbelievable if we apply AI from, I don't know, health, finance, autonomous driving. Why are those models here suddenly have these massive limitations? Well, it has to do with marketing, yeah? Let's look at this study here from Tsinghua University, yeah? A multi-agent framework for long story generation. And I posted this, I think, 2 days ago, 1 day ago, 2 days ago. So it is 4 days old. Okay, this is not valid anymore, 4 days, but okay, let's make an exception. Let's say it's good for us. And the question was, can our current LLMs not even write a simple story with more than 1,000 words that is coherent? Look at the study and they show us, no, they have massive problems. And what we need, and always they find a solution, which is great. But the solution here is to say we need to decompose the complexity of a 1,000-word story into, one LLM is not able to do it, so into 3 agents. The first agent is an outline agent, and it generates here a 10,000-word story about something specific. And then we have the planning agent for the different events and for the different chapters and from the different persons or people or whatever happens, features. And then it all comes together here. We have then the writing agent. And the writing agent does not have to care about what story should I write, what events should happen, what about anything. No, he has all the information from the outline agent, he has all the information from the planning agent, all the events that are gonna take place, all whatever complexity gonna take place. He just has to write it, finalize it, write it down. And they say, yeah, this is not a solution. And I said, this is not possible. It is not possible. We have a token context length here of more than 1 million, 2 million. And now we found out now at the end of June, our LLMs have a problem to have a coherent data flow and a coherent feature of more than 1,000 words. I think it's amazing. Third, the best at last. So, June 23rd, 2025, University of Derby, beautiful. A temporal causal probabilistic description logic for developing logic RAG agents. And you say, unbelievable, RAG is dead. No, RAG is not dead. We have it here again and we combine it now here with a probabilistic description logic, a mathematical logic. Heaven's sake, so where we are here in the area of temporal description logic, causal reasoning, probabilistic knowledge representation, Allen interval algebra, knowledge graph, and everything else. So what they find, the authors tell us we have a core problem identified. LLMs are great. They are master of syntax and statistical correlation, unbelievable beautiful. But LLMs lack a formal grounded understanding of concepts that are crucial for the real-world reasoning path. And the first is temporality, second is causality, third is probability. It is not there in our LLMs. So therefore, they propose now kind of a new neuro-symbolic framework. They call it here temporal, causal, probabilistic description logic. A new logic framework, a logic solver. So they say, listen, doesn't make sense. The LLM is not able that we can train it on this. So we do, like when you code, no? You have a Python environment, C++ environment, whatever environment, you have a coding environment separate to the LLM. And in this coding environment, you execute your Python files and you get a numerical result. And the result goes back to the LLM. And then the LLM, given the numerical result by the numerical computer simulation of a simple Python file, then continues with its reasoning. And they say we have to do the same. But now here with a complex logical data structure that is based on RAG, Retrieval Augmented Generation context. Unbelievable how we close here the context. And they say, yeah, we propose this. And I think it's beautiful because it kind of fuses together quite a lot of field of research. No? Everything from this descriptive logic that we have here to the temporal operators to explicit causal operator like phi. I'm going to show you an example in a second, and some probabilistic tags. Because finally, it's not enough to have in the language, yeah, maybe this is going to happen. No, be more precise. Let's come here to a mathematical solver based on logic expression that is now doing here the reasoning process. What a beautiful idea. So their grand vision, if you want, is a logic RAG for agents. No? So beautiful, translate natural language queries into the formal TCPDL formalism. Do it. This is now a formal reasoner. And then the result translated back so that the LLM can use it and continue with its reasoning process. Simple, beautiful, but not as easy as you might think to set up, because we do have Logic Solver already, and they have here, and this is my demo, the way I understand it here, an LLM output. Now we imitate here the reasoning process, and this is simply about smoking, and what about the risk factors here, and what about blood pressure and type and everything. Yeah? And now this human English sentences would be translated now in a kind of formal reasoning representation that looks like this. So you have kind of a coding formalism where you code this into formal machine-readable axioms. And you see here clearly on the left side, you have here the human story. On the right side, you have here kind of a formal machine-readable mathematical equation that is optimized for logic, for causal reasoning tasks. Really interesting. I just discovered it today. I have not tried it out. I'm just trying to understand it and share my knowledge with you. The LLM output of, hey, this is a risk factor, no? Or this is the result of. Yeah, it becomes a mathematical operator. So you see what we did with coding, with Python. Now we try to copy this idea. Hey, let's build here a formal solver for our topics. No? And now this operator here, the LLM uses here correlational language here, learned from medical text, from medical textbooks. But now in this new solver uses here a dedicated logical operator phi. And this is really, the meaning is a sufficient cause of. And this is not just a strong association, but it's a formal causal assertion that can be used now in logical proofs, transitivity, element, and so on. So you see, you have to have a broader knowledge really about what is it that causes what are the relations between those elements, give me the probability, the densities, and the numerical factors. So we leave here the language behind with results, with topics like, hey, this is a leading cause of, and we say, hey, we understand the mechanism, we understand the probabilities, we understand what's happened next, we understand here the cross or counter references that happening in this system. We have to be much more precise than the human language if you want to have successful logic solvers. Great. Outlook. I think I've changed this video. I want to show you not one new publication that you can read and enjoy, but what about cross-selection, cross-topics, multiple 5 titles, 10, 12 publications. On a day, they show you clearly what is the hot topic. What are people trying to solve? What problems are we trying to solve? And I think, beautiful, no? The self-consistency paper here, a powerful diagnostic tool revealing here the symptom. LLMs are fundamentally unreliable. And if you had the impression that here on my channel, I tell you, hey, LLMs are just beautiful. Yes, but they are fundamentally unreliable. You have to be aware of this fact. Second here, our ConciseHint PDF, our paper here on the inefficiency of current chain of thought, offering here a way to make the reasoning process more practical and less costly. And third here, absolutely interesting, a radical cure here for that our LLMs are not really excel here at logical causal reasoning on higher complexity, build an external mathematical solver. We have already quite some solvers, but build an advanced one, beautiful, augmented with an external formal reasoning engine, creating here a more powerful neurosymbolic hybrid model. Whatever research goes in this direction to improve the reasoning of our LLMs. And you know, LLMs are the heart, the intelligence, the brain, the main core element of agents. So without here better LLMs, your agent will not improve at all. And you can add as much memory or as much connectivity. You need the reasoning capabilities of LLMs, and they are the core, the heart, the brain of your agent. So what are the challenges we face today with LLM? And just looking at today's 5 papers on this. And I think we have a great coherence, because also I looked at more than 200 papers for today, and I did not find one paper that contradicted those sentences or those findings by those 5 papers. So challenges are causality. Causality is still a critical weakness in LLMs. Don't get me wrong, LLMs are master of correlation, but not of causation. Causation is the main weakness of an LLM. Second, probability. We have fuzzy terms in our human language. Now, likely, probable, yeah, there's a small chance or rarely this is happening. But this is not what we're looking for to have some complex reasoning engines, no? If you have a complex mathematical problem, if you want to go, I don't know, calculate here something specific, if you want to build a rocket to go to Mars, or just for autonomous driving, a small chance is not good enough. You have to quantify this. No? Also, our LLMs, they have problems with continuous updates, their learning process. No? If new evidence emerges, it doesn't systematically update here its prior belief. Yes, you can have, hey, this is a new fact, this is a new reasoning pattern, but it is not integrated deeply into the layers of the LLM. No? It just generates a new, plausible sounding sentence that incorporates in a way the new information, but it is not deeply interwoven in its reasoning patterns that were generated by its pre-training datasets. So you see, today, a very bleak, almost a dark picture here. What are LLMs doing? What are the strengths and the weaknesses? But I think it is absolutely important to make everybody aware LLMs are not perfect, not at all, not even close. LLMs have massive limitation, and if you do and put your LLMs somewhere in a critical process, be aware of this limitation. And I hope I've given you today, with the latest AI research on this topic, some further insights. If you're interested in this kind of videos and want to see more of this, well, why not subscribe? And I see you in my next video.